talks. We'll start with Sharvari here. What I'm throwing on the table for you, Sharvari, is policy on e-mobility at a country level, not at a global level. You'll not finish in 5 minutes. The DPI for electric buses that's evolving in India, and where you see the market and the big guzzler vehicles like trucks, etc., where you see them going, and of course, a little bit on your perception on the charging infrastructure. Thank you.
Thank you so much. Good afternoon, everyone. And we absolutely understand that you are just had amazing lunch. So we'll try and keep it as interesting as possible, if possible, even interactive. As on date, like till last month, do we have any idea how many electric all vehicle classes put together, are registered across India? Any guesses? Any guesses? People can shout from audience. Got to offer a price. 5 star. Okay, 5 star. How many vehicles have been registered, electric vehicle have been registered across vehicle classes, right from two-wheeler to truck? Any guess? It's in 5.5 million.
Yeah, somebody got it, right? Somebody said 50 lakhs.
It's exactly 5.5 million. It's not a small feat. So if we look at our journey, policy has been one of the key drivers, and it actually dates back to National Electric Mobility Plan, which you can call it as a seed of electric mobility tree in the country. And we have kept orchestrating policies across various vehicle classes. One of the major policies which I think all are aware are FAME 1, FAME 2, which are essentially incentive program for people to buy electric vehicles. We agree that they have played a major role because in the initial period, it is essential to create that early market. But going forward, we also need to look at those non-financial policy levers which will help us to sustain this particular growth. I think I'll pick up one example in terms of how we have evolved as a country, and a favorite example comes from electric bus because that is something we all relate to immediately. If we remember the FAME 1, which was the first incentive program, we had given incentive for outright purchase of buses, and state transport unit have got those buses. But we had our own share of difficulty in operating them, maintaining them. Then we changed the model. We learned from FAME 1, we changed the model. We said, okay, let's not give upfront incentive. Let's see if we can do demand aggregation and bring down the cost. We went to demand aggregation, got GCC model, and the price fell. We got approximately 5,500 buses. That was the major, probably at that point of time, that was the largest electric bus tender across globe. After we realized that, because of the gross cost contract, these buses went on the books of OEM. There are OEM representatives sitting here. And the state transport unit changed its role from operator, who used to operate these buses, into regulator. After GCC, they started becoming regulator. But even after that, we faced the problem, there was no enough payment security. We came up, like that's a third lever we got, which is the payment security mechanism. That's how we have evolved, and then we realized there are still many cities across India who do not have enough public transport. Then we came up with PM E-Bus Seva. So if we see the learning curve, we have actually bettered ourselves at every stages. Does that mean we are okay now and we don't have problem? We do have a problem. And probably in the, to continue the bus sector, as on date today, if you pick up ticketing system, if you pick up vehicle specification and battery health, if you pick up route rationalization, And if we pick up scheduling, these are four independent pillars. We look at them as an independent pillar. As a passenger, what is important for me? I need to know when the bus will come to my stop. Will I get place to sit or stand? From a financer perspective, they are bothered to understand what does vehicle cost, how much it will last, what would be the battery health, and what would be the residual value at the end of XYZ years. So each one of us are looking at the same problem from different perspective, but there is no common interface which bring all this system together like a Lego block. So there is a main concept which is now getting rooted, which is digital public infrastructure. For each one of you, we can relate easily. We had banks earlier, we had mobiles earlier, we had internet earlier. But what UPI did, it gave a platform where we can seamlessly now talk to each other, and while we talk to each other, we are still securing what we need to secure. That means there is a platform possible. You imagine it's a very basic principle which we applied in UPI can be now applied as a digital public infrastructure for electric bus, because we are talking about 5 lakh buses going forward. So this is about bus. I have another 1 minute I will use probably for next big guzzler, which is trucks. Till today, whether it was FAME 1, FAME 2, or probably any other policy which got drafted, at national level, even at a state level, one of the vehicle class which was in a way not captured pretty well was commercial freight vehicle. Just to give a number check, they are only 5% of vehicle population, but in terms of road transport, they have 34% of emission. That's the guzzler they are. So, and credit to Professor Karthik and his team here, we got to work together on Bharat Zero Emission Policy Advisory, which actually lists down what could be multiple policy levers which can make it happen. And typically when we talk about electric vehicle, nowadays people know that there are incentives from central government or state government. But other than incentive, there are regulatory mechanisms like CAFE norm. There are infrastructure interventions which we can have. And there are business interventions which we can have, which can be accelerated depreciation or lower cost of interest, all of that. So right now we are standing at a juncture as a country where we need to do right orchestration of policy. And I think I'll end here and we'll revisit few questions in next round. Thank you so much.
I don't think it's there. Thanks, Sharvari. I'll turn to Sundu next. You've got a mic. So I was wondering if you can give us some insights on intermodal transportation and also the way energy is going, the energy for transportation, where you're seeing it evolve, especially in the context of big guzzlers like trucks. And where exactly, and this includes your digital twin kind of tool for development or safety tools for public operation, where you see AI actually impact these supercritical areas. Like safety is an important aspect, and we will need the development and the operations to be fairly empowered. Do you see AI as a tool in this? So if you can give us some initial thoughts on these.
Good afternoon. So first, intermodal transport. There's one area where we have done badly all these days. But slowly with metros coming in, I think there is a lot more recognition that if people need to use public transport, it has to be multimodal. You have the first mile, you have the last mile, and even the mid mile need not be one single mode. You have multiple things. And a lot of people don't use public transport only because of this switching between modes is very, very inefficient. It makes your overall travel unpredictable, and the delays kind of add up. Uh, but again, today with metros, you see a lot more focus, at least physically switching from one mode to another mode has been made a little bit easier. I mean, earlier for those who use Madras, Chennai Central Station, if you want to go from Park Station to, which is the suburban rail station, to the main station, you had to just walk, cross the road, and kind of content with the traffic and all that. But now with metro coming in, at least there is that central square. You can do the switch with some level of safety. And there are escalators. So again, with the population in the state that it is at today, where people have trouble climbing stairs, even youngsters. So their escalators help. But even with all that multimodal thing in public transport has some way to go in terms of ticketing. Today, you have to purchase tickets separately. With that Bharat Mobility Card, again, that has been in the works for almost 3-4 years now. Only now, at least Chennai has started implementing it. That is, again, one more pain point removed. Next, if we need to actually look at schedules. So how can we kind of synchronize so that you don't waste time when you switch from one to another? This is in terms of people transport. Then when it comes to cargo, today trucks dominate logistics in India mainly because there is no proper mechanism for this multimodal cargo. I mean, even if you take trains have the potential to become the largest cargo carriers, but that first mile, last mile, that's a big challenge. The inefficiency, the cost increase, and damages to the goods. So all these kind of create a problem for having a proper multimodal transport system. There have been efforts. Again, there was a initiative to do roll on, roll off. The entire truck rolls onto the train carriage and then again rolls off at the final thing. But for whatever reason, that has really not taken off. It is time we kind of address these issues so that holistically we find a better solution. Electrifying trucks is one part, but that's does not address all the problems. So if we can spend the time to evolve a multimodal cargo transport mechanism, that will help a lot. There are a lot of challenges, and I mean, I'm happy that it's been part of today's panel discussion. Next one is AI, I mean, digital twin. Energy, okay, yeah. We've been having a conversation over lunch itself on energy mix and what is ideal in terms of various aspects. Again, energy is such a complicated topic that I mean, you can look at it from multiple aspects. So energy security for the country as a whole is one, emissions is another, and then cost obviously is a very important part of that. So one question almost everybody asks when we talk about electrification, especially when it comes to electrifying trucking, is does India produce so much energy? So today, if you want to convert obviously all the trucks into electric trucks, we don't produce the energy, but typically all these transitions happen slowly. So if you look at it that way, again, one calculation was we probably need a lot more energy for air conditioning as compared to energy required for transport, especially for cargo transport. So that is a problem. India as a country is going to need a lot more energy, and we are investing, and today we are investing in, again, all forms. While renewable energy is an important thing, we are not just sticking to renewable energy. Even now, coal plants are getting commissioned, they are getting, I mean, new plants are being installed and commissioned. So energy problem is another, I won't say it's a problem, it's just that we need to add capacity. That's the only problem. And we have to do it in a way that is judicious. Again, across all these aspects, whether it be emissions, whether it be cost, whether it be energy security, those aspects. And finally, the digital twin. See, okay, AI can definitely help in building these digital twins faster and with lesser, not exactly complexity, but lesser understanding of the complete underlying physics or whatever other phenomena that govern. But originally, when the concept of digital twin started, it was more a physics-based simulation of the real-world system. Now, obviously, we know that as systems become more and more complex, you have more and more challenges in capturing the real-world behavior in a simulation better. That is where AI is kind of trying to help or bridge. But AI is a double-edged sword. Because in order to build an AI model, you need past data. And if that system changes, then how long before you realize that what the AI predicting is no longer in line with what the way system has changed. So as of now, I would say AI in digital twin has some way to go or some distance to go. We still don't have enough data on where required. So Sharvari was talking about that DPI in the electric bus kind of a scenario. Even overall transport, if you look at overall statistics in India, how many people use public transport, how many people use public transport for what purpose, where are they going from point A to point B, all that we don't have clear data. We know that so many people travel from, let us say here, Kasturba Nagar MRTS station to the central. But did they come from IIT? Did they come from Adyar? That data is not there. So how do we even build a digital twin model or was a AI model in order to kind of simulate all this and to make the necessary interventions? Again, I'll stop here and we can probably continue.
We'll take it up with Kannan. We'll allow you to stop at 2 or 3 minutes if you want to. So a little into engineering now, Kannan. So I was wondering what your thoughts were on the machines, the drives, right? Whether, of course, everybody is using PMSM predominantly right now. And even though the flux direction is looking to be changing, we still seem to be nicely committed and addicted to magnets. So where do you expect these machines to go? Do you see any new machines coming in, like, I don't know, linear actuation or whatever? Similarly, where do you see the power electronics going? We started hearing from people about gallium nitride systems, which are at about 600 volts these days. And some people are saying we'll take it up to 1.2 kilovolts. Less than 6 months ago, I thought beyond 300 volts, if somebody was talking about, he was an idiot, right? So where do you see power electronics headed? Where do you see the drives headed? What are your thoughts on this?
Yeah. So, see, primarily the big move, pardon my voice, in the last few decades was we moved away from what is called asynchronous, like induction machines, and we moved to synchronous. And the fact that we started using rare earths, that made the motors a lot more compact than they were before. And I think once we have got accustomed to the convenience of a compact motor, it will take a lot of persuasion to make people go back to something that is very clunky and large. In terms of direction, what I see is, yes, the fact that we are using powerful rare earth magnets, all along there is a sort of worry that is gnawing everybody's head because it's something which is monopolized by just one company, and if suddenly the switch were to be turned off, it becomes a big supply chain risk. So one direction that I see now many people are taking is, can I use less of it? Not that I'm not using any of it. So are there designs and topologies where I can get same performance by using less of the stuff? And turns out, yes, one can. It's just that we didn't pay enough attention to it, but now it is getting noticed more. So that's the example of axial flux. And the other direction that, again, many people are pursuing is, I don't mind if the size is, say, 20% larger. I'm not talking about something 4 or 5 times larger. But I want all the advantages of control, precision, quick acceleration, all the things that the contemporary motors have made possible. I don't want to go back to something that is an old legacy system. So if that is the situation, then what is called synchronous reluctance, with a little bit of weak magnets added to improve the quality. That is a very attractive option. And I'm saying that many people are focusing work there where the space constraint is not very stringent. So these are broadly the directions as far as the motors are concerned. The other big happening area is that there is continuously a move to go towards higher and higher voltage. I remember in the very early stages when just bicycles were powered with some small motors, we used to have 12 volt or 24 volt motors because it was considered okay. And then 48 became a kind of standard, then 72. And I don't know, Ola, what is the voltage? Below 60. Yeah, so, but progressively people are realizing that if you have a low voltage, then you have to compensate for the same power by putting more current on the DC side. And that will mean you have very clunky conductors or a lot of inefficiencies. So there are definitely advantages associated with higher voltage, especially if you're talking with higher power. And so now people are talking about 600, 800 volts, and this is largely possible because of the wide bandgap semiconductors. And these can not only withstand or support the high voltages, they also give reduced losses, and most importantly, they can switch much faster, much higher frequencies, and improved switching frequency with lower losses also gives us a lot of advantages in terms of performance. The challenge is that when you switch a very high voltage rapidly up and down, then design becomes a challenge. There's a lot of radiating noise. So engineers are still coming to grips with that. But these are the broad trends that I see.
Thanks, Kannan. So just we'll come to two-wheelers now. So first, the big question, including motorcycles, if you gaze into the crystal ball, when do you see 80% of two-wheelers in India being electric? No? That's one, everyone wants to know. So that's a popular topic more than anything. I'd also be interested in you giving us some perspectives on how connected vehicles are panning out, whether we know that it's very useful in business vehicles. Commercial vehicles, there's no question, it's a no-brainer. But where do you see connected vehicles adding value to personal journeys and for personal transport? And in this process, where are you seeing this architecture go in, let's say, over the next 10 to 15 years? How do you see the architectures? I know it's going to be a little different for the different segments, but at least for the two-wheeler segment, where do you see it? Or if you care to talk about other segments, more than happy to.
Yeah, good afternoon, everyone. So the first question is about adoption of EVs. I think it's just imminent. It's going to be very fast. I can't put number of years on it, but it's going to be like the smartphone evolution. Just moved from dumb phones to smartphones. Even reluctant users like me who didn't want to touch the screen moved pretty soon. So when technology advances, when you get a better product for cheaper, it is very, very lucrative to just move, and you won't even feel the change. Right now, we can't imagine lives without smartphones. So I think that's the same that's going to be for EVs, including motorcycles. So there are technological hurdles, of course. Just like smartphones pass those, we are passing them. My own company is coming with a motorbike pretty soon in a couple of months. The two-wheeler scooters already have displaced all the premium scooters. Above 1 lakh category, very less ICE scooters are sold right now. It will be less than 10% of what they was being sold 4 years ago. As of now, there were 2 million EV registrations last year, which is almost 8% of the total vehicles sold. But the premium vehicles were 30%. Just like the iPhone story, first the premium ones get converted, then the rest will do. So we are following the same trajectory. Within a few years, we'll move there. About connected vehicles for personal transport. I'll also include a little bit of the commercial transport. The biggest use I see for them right now is ADAS. That is, trying to figure out where the other vehicles are. So you get driving assistance in braking, in avoiding collisions, in understanding what the signals are. So it also increases safety. If there's a red signal, the scooter will not allow you to move. Then we are already connected when we are using our mobile phone while driving for maps, for talking, for understanding how long it will take for us to reach. And we're getting a lot of information from other users on the road, whether there's traffic or not. So in a sense, we are already there, but the vehicle per se does not make a lot of decisions based on the connectivity. Now those decisions will start coming in. A lot of it will have to do with regulations. Just like I said, your scooter will not move if there's a red signal. Same is going to be for tolls on the road. Our Navig system is very good that it can also detect lane change. So we can detect whether we are on the highway or on the service road. So whether you're going to be charged or not, how fast you were, what kind of lanes you're using, whether you're on the flyover or not. So regulations will also start kicking in with connected vehicles. So I think that's where the next step where we start noticing would be. Otherwise, it will be very incremental change, and we'll take it as part of life. This is how things already have been. So the architecture right now, there's a generic, way of looking at developing technology, which comes from what already exists. That's how electric vehicles are built right now. What used to be built earlier, we are replacing that with motors. So engines we're replacing with motors, gas tanks we're replacing with batteries. The philosophy is the same. The mobility of the future will look quite different. I can keep going on and on about it. But the architecture for connected vehicles will be, as of now, every individual part, the screen, the motor, the battery, they all have different controllers. They have different, they just talk to each other. And they try to do a complicated job one at a time. The architecture will be central in the future. It definitely will be, because it will be cheaper and better. A central processing unit which will talk to all these peripherals which are not so intelligent and gather all the information, make them work optimally, and also connect to the cloud. And the overall electronics architecture will move this way. The vehicle architecture will be quite different to imagine. We can have another talk about that.
Thank you.